Hello everyone, this is D. Chinnagokari. Welcome to our chemistry channel, that is Chemistry Masters Academy. So in this video lecture, I am going to explain about the IUPAC nomenclature of aliphatic hydrocarbons with complex substituents along with IUPAC nomenclature of alkenes and alkynes. Okay, so now let us start our concept, that is IUPAC nomenclature of aliphatic hydrocarbons with complex substituent. So first of all, complex substituent. Complex substituent. So here what is a complex substituent? Complex substituent, it is nothing but if substituent is present on the substituent, that is called complex substituent. If substituent present on the substituent, if substituent present on the substituent, such type of substituents are called complex substituent. Complex substituents. For example, so let us consider this is the longest carbon chain and here it is the substituent. If substituent, this is the another substituent which is present on the substituent. So it is, let us consider it is the longest carbon chain or parent carbon chain. So now it is the substituent and here we are having substituent on the substituent. Such type of substituents are called complex substituent. So here when we are going to write the name of such type of organic compounds, so we should write the name of complex substituent in the brackets. Okay, so by opening the bracket or parenthesis, we should write the IUPAC name of this compound. Okay, first we should write the name of this complex substituents. So however, we follow the basic nomenclature of these organic compounds, means basic structure of IUPAC compounds. So we are already aware about what is the basic structure of IUPAC, that is secondary prefix plus primary prefix plus root word plus primary suffix plus secondary suffix. Okay, so this we follow. Okay, so here what we are going to do somewhat different, means when you are writing this name of this complex substituent, we are going to write in the bracket by mentioning the position of this complex substituent. Okay, so now let us go through some examples, we can get more clarity. Okay, right, now let us take an example here to understand this concept. Okay, for example, so this is one organic compound here we are having. So now let us count the number of carbon atoms from all possible directions. So here when you count the number of carbon atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon atoms are there. So here when you are going from this direction, we are going to get the fifth position, and when you are coming from this direction, 1, 2, 3, 4, 5, fifth position. Okay, so now this is the position of the substituent, and when you go from here 1, 2, 3, so from here we can know very clearly, when you go from this direction, we are going to get the less number of carbon chain. Okay, so now this will be the longest carbon chain, and now it is the substituent. So here when you see in the substituent, here we are having again substituents present on this substituents. Now that time how we are going to deal this and how we are going to give the name of this organic compound. So here, first of all, what we should do, we should start here also we should give numbering for the side chain. So here, first number we should give the carbon which is connected directly to the main carbon chain. So 1 or 1 prime. Then after we should go in which direction we will get the more number of carbon atoms. So in this particular examples, in all directions we are going to get only 2 carbon atoms, and these two carbon, this carbon and this carbon is not included in the this side chain also. So these are what substituents present on the substituents. So such type of substituent is called what? Complex substituent. Okay. So now let us write the name of this compound. Okay. So first, where is the position of the substituent? Fifth position, 5. So immediately we are going to start a bracket. So on this substituent we are having 2 methyl groups, and at which position? At first position, 1 prime comma 1 prime dimethyl, and here in the substituent how many carbons are there? 2 carbons. So that ethyl, dimethyl ethyl. Immediately close the bracket, and next come to the primary prefix. So it is open chain only, no need to use of any primary prefix. When we use primary prefix, when it is cyclo, bicyclo, spiro, in such type of compounds only we use primary prefix. Okay. So here it is open chain compound, no need to use of a primary prefix. Next to root word. Here root word means we already know number of carbon atoms in the longest carbon chain. So here how many carbons are there in the longest carbon chain? That is 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 carbons are there, means none N. Okay. So none N. So the name of this compound is 5. Immediately we are starting bracket, and we are writing the name of the substituent in the bracket. Why you are writing in the bracket means it is a complex substituent. So here 1 prime 1 prime dimethyl ethyl nonane. Okay. So now let us take one more example. Okay. So now let us consider such type of example here. Okay. So now numbering. Now we should give the numbering. Okay. Let us consider here also. We will take one more substituent. Right. Okay. So now let us give the numbering in all possible directions. Okay. When you see the numbering in all possible directions, first let us go through in this direction. 1, 2, 3, 4, 5, 6, 7, 8 carbons in this direction. And when you come from the bottom, 1, 2, 3, 4, 5, 6, 7, 8. And so when you go in this direction also you are going to get water. So I use in the different color so that you may not get any confusion. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And when you go in this direction, 5, 6, 7, 8. In both the direction we are going to get the same number of carbon atoms. Okay. So now let us do somewhat modification here. Let us add one more carbon. 8 and 9. So in this direction we are going to get the 9 carbon atoms. Now which one we should take? Which one we should take? ninth carbon. So here straight one or this bottom one means a green color with 9 carbon atom. This side 8 carbon atoms only absolutely. So this is not a parent carbon chain. But here with black color also means here left to right we are having 9 carbon atoms from here bottom onwards. With green ink I written here we are having 9 carbon atoms. Now which one is correct here? Both are having the same number of carbon atoms. So in that case we are going to select the carbon atom which is having or the carbon chain which is having more number of substituents. Okay. So when you go in this direction we are having 1 2 substituents only, but when you go in this direction 1 2 and 3 substituents are there. That's why we are going to consider this is the longest carbon chain, which means which is written with the green ink. Okay. So now this is the main carbon chain. This is the main carbon chain. Okay, 9 carbon atoms are there. Now here it is the substituent. Okay. So now let us name this compound. Okay. So now this one is not included in the longest carbon chain, it is the substituent. So when you observe here it is not a simple substituent, it is a complex substituent. Okay. So when we are having complex substituent, so immediately we should give the numbering, that is 1 prime, 2 prime, 3 prime, and here 4 prime, and here also 4 prime, 4 prime. Like that we are giving numbering in the substituent also. Now let us start the name of this compound. First we should write the name of substituents. So here we are having methyl substituent. It is also methyl substituent, only one carbon is there. Here one substituent, this is one substituent, it is also one substituent. So when you are having more number of substituents, we should write the name in the alphabetical order. That rules I have explained in the last video. Okay. So now here this is methyl, this is also methyl, and this one 1 2 3 4 butyl. That's why we are going to write this name of this complex substituent. Okay. So now first where this complex substituent is present, that is 4, sorry not 4, fifth position, 5 dash immediately 3 prime methyl, 3 prime methyl and butyl, 3 prime methyl butyl. Okay. 3 prime methyl butyl and 2 comma 3 dimethyl, 2 comma 3 dimethyl nonane. Okay. So this is the name of this complex substituents. So here we are using purely IUPAC names, but in some IUPAC names what they will use, they use the common name or general name of this complex substituents. Okay. Sometime in textbook also we can find the in the IUPAC name, here they will write the common name of this or general name of this complex substituents. Now let us see what are the general names of some complex substituents, important complex substituents. Okay. Right. So here we are going to take the structure IUPAC name and common name or trivial name, anyway. Okay, common name or trivial name also we can call that. Okay. First let us see some structures here. First CH3, CH2, CH2. Now this carbon is connected to the longest carbon chain. So now simply what is the IUPAC name here? Three carbons are there. The terminal carbon only is connected to the longest carbon chain. So IUPAC name generally we use as the propyl. Propyl. And what is the common name here? That is N-propyl. N-propyl. N-propyl is the common name. Next to CH3, CH, CH3. So here the middle carbon is going to connect the longest carbon chain. Then what is the IUPAC name here? IUPAC name we already know. When we are giving IUPAC name, first we are going to give numbering. Even it is if it is substituent also. So numbering here 1 prime. So here also 2 prime, here also 2 prime. So 2 prime. So here what is the name of this complex substituent? Means 1 prime methyl, 1 prime methyl, and here how many carbons are there? 1, 2. 2 carbons are there, that is ethyl. This is the name of this complex substituent. And what is the common name here? Common name, it is called isopropyl. Isopropyl. Okay. Next to CH3, CH2, CH2, CH2. And here this last carbon or terminal carbon is connected to the longest carbon chain. Now what is the name of this substituent? So it is a simple substituent only. So what is the IUPAC name here? Generally here how many carbons are there? 4 carbons. 1, 2, 3, 4. So it is named as what? Butyl. We already know. And what is the common name here? Simply we add N-butyl. N-butyl means normal butyl. Normal butyl. Last carbon is connected to the longest carbon chain. Next to CH3, CH2. Okay. CH3, CH2, CH3, CH. Now, so for the sake of okay, CH3. Now this carbon is connected. This carbon is connected. Means that not a terminal carbon. This middle one carbon is connected to the longest carbon chain. So now what is the IUPAC name here? Generally as usual we give the 1 prime here by because it is connected to the longest carbon chain. Next to here 2 prime, here 2 prime and 3 prime also we can write. That's why this side only we are going to write 2 prime and 3 prime. Now what is the IUPAC name here? As usual at first 1 prime it is having one CH3 substituent, that is 1 prime, 1 prime methyl. Here how many carbons are there? 3, that is propyl. 1 prime methyl and propyl. And what is the common name here? Isobutyl. It is called isobutyl. So here when you observe generally here this common name includes the all the carbon atoms, that you can understand here. See isopropyl 3 carbon atoms, isobutyl 4 carbon atoms, but linkage is different. Next to CH3, C, CH3, CH3. Now this carbon is connected. So now this is one another possible structure here. So now this carbon is connected. So now what is the IUPAC name of this compound? That is, so here as usual we write 1 prime. Why? Because it is connected to the longest carbon chain. Now here 2 prime, here also 2 prime, and here also 2 prime. So anywhere you can write 2 prime. Okay, anywhere we can write. So now what is the IUPAC name? 1 prime comma 1 prime dimethyl and here it is contained 2 carbon atoms in the longest carbon chain, that is 1 prime 1 prime dimethyl ethyl. Okay. Next what is the common name here? Common name of this compound is tertiary butyl. It is called tertiary butyl. Okay. Next, let us see one more important one, that is CH3, CH2, 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 CH2. Okay, so here total how many carbons are there? 5 carbons are there, and this carbon is connected to the longest carbon chain. Now what is the name here? IUPAC name. Here 5 carbons are there, means pentyl. Okay, and what is the common name here? Common name means here n pentyl, normal pentyl. Okay. Next, let us see one more variation here, that is CH3, CH2, CH2, CH, CH3, and now this carbon is connected to the longest carbon chain. Now what is the name of this compound means? So as usual, we will write the numbering 1 prime, 2 prime, 3 prime, 4 prime, and IUPAC name is 1 prime methyl, 1 prime methyl butyl, 1 prime methyl butyl, and common name is, what is the common name of this compound is isobutyl, isopentyl. It is called isopentyl. And one more structure, that is I am going to write here. Okay, so first structure I am going to write CH3, C, CH3, CH3, CH2. So now like this structure is there. So now it is the substituent. Okay, so now what is the IUPAC name? IUPAC. So what is the IUPAC name of this compound? So generally this carbon is connected to the longest carbon chain, 1 prime we will write here. Then after 2 prime here. So here if you come this side 3 prime, here also 3 prime, here also 3 prime. So 3 prime. So what is the IUPAC name of the compound? That is 2 prime comma 2 prime dimethyl. Dimethyl. So how many carbons? 3. Propyl. Propyl. Okay. Next, common name. What is the common name? Common name is neopentyl. It is called neopentyl. Okay. So this is about some important complex substituents and their IUPAC names and common names. Okay, right. So now let us see some examples. Okay, so by using the common names and IUPAC names, let us practice some examples. Okay, so you can note down or you can take a screenshot. Next, you will see the some examples. Okay. So now what is the name of this compound? Okay. Now let us try to give the name of this compound. First numbering. So numbering here. So from here also, here onwards when you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons are there. And from here onwards 1, 2, 3, 4, 5, 6, 7, 8 carbons only is there. Means 10 carbons we can count the longest carbon chain. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here. Here also 9 10. So now which one we should select? So when you are having like equal number of carbons in the two possibilities means, then we should select the longest carbon chain which contain more number of substituents. See here, when you observe clearly, here we are having two more substituent, but here when you come only one substituent we can observe. That's why, so now we are going to take, this is the number. Okay, now let us see substituents. Here what are the substituents? Okay, what are the substituents here? Okay, so this is one substituent, and this is also one substituent, and this is also one substituent, this is also one substituent. Okay, so now what is the name of this substituent? So now when you observe here, it is a complex substituent. So here carbon, carbon, carbon and carbon. So here IUPAC name also we know, and common name also we know. What is the common name of this? Tertiary butyl, tertiary butyl. And whereas IUPAC name is 1 prime comma 1 prime dimethyl ethyl. This is the IUPAC name of this substituent. Okay, so now this is methyl and this is also methyl, and here 1 2 carbons are there, this is ethyl. Okay, methyl, and this is methyl. Okay, now name this compound. How to give the name of this compound means, so first we write the name of substituents, primary prefix, root word, primary suffix, secondary suffix. Here no need to worry about primary prefix and secondary suffix. Why? Because here this is open chain compound and there is no functional group also, right? So what is the name of this compound now? So we should write the name of the substituents in the increasing, or sorry, in the alphabetical order. So in the alphabetical order, first ethyl will come, that's why 8 ethyl, 8 ethyl, and then after methyl ethyl, methyl ethyl will come. Okay, so therefore what is this, where it is present? 5 dash 1 prime comma 1 prime dimethyl, dimethyl ethyl, dimethyl ethyl. And here what is the name of the substituents? Methyls. Where they are present? 9 comma 9 dimethyl, dimethyl. Okay, so next root word dec, n, decane. So this is the name of this compound. Okay, so you can practice the more number of problems in the, by seeing the textbook or NCRT or in any IIT books. Okay, so now let us discuss about the IUPAC nomenclature of alkenes and alkynes, substituted alkenes, substituted alkynes also. Okay, so for practice you try to give the name of this compound. Try to give this the name of this compound. Okay, comment the name of this compound. Okay, so while writing the name of the compound, you remember the basic structure of IUPAC and what are the rules we have discussed while naming the this aliphatic hydrocarbons with simple substituents and with complex substituents, and also numbering, how to give the numbering rule, and priority, lowest sum rule, and first point of preference rule. Everything you recall and try to give a perfect name for this. Okay, next let us see nomenclature of alkenes and alkynes. Okay. So here we already know alkenes. Alkenes, C double bond C, alkynes, C triple bond C. So this is the alkene and alkyne. And here when we are having double bond or triple bond, so this double bond and triple bond we are considering equal priority. They are having equal priority. So that we are going to give same priority except in symmetric case. What are the symmetric cases? So in symmetric cases we'll go through the alphabetical order. So means in the symmetric cases we give priority for alkenes when you compare to the alkynes. So while discussing examples we can get this type of clarity solves. Okay, first here we should make one rule here. What is the rule means, children? We should make one rule. So here the longest chain must contain the longest carbon chain must contain the longest carbon chain must contain more number of multiple bonds. Multiple bonds. This is the only rule we are going to add. Okay, so even though the longest carbon chain contain less number of carbon atoms, it should contain what? Multiple bonds when the multiple bond is present. So here we can make one priority order likewise. Okay, so first we should give priority for the double bond or triple bond, then after substituents. Okay, then after only substituents. First we should consider the double bond or triple bond, then after we should give priority for the substituents. Okay, now let us see some examples. So here more and more number of examples and more number of rules we will discuss while discussing the examples. Okay, so at a time only I'm not going to give all the rules. Why? Because it is like a by heart method. Okay, the simple rules we are going to learn, and based on that rule some examples, then after some rules I am going to add. Okay, so your longest carbon chain must contain what? More number of multiple bonds. That you keep in mind. That may be double bond or triple bond. Okay, so already I told that they are having equal priority. Okay, so now what is the name of this compound? Okay, so here simple substituent, simple compound. Here only one double bond is there. So here from where we need to give numbering? While giving numbering, so this is also important. While giving numbering, what we should do? We should give lowest number. We should give lowest possible number. Lowest possible number. Lowest possible number to the multiple bond. To the multiple bond. Okay, see, so lowest possible number here. So here we can start 1 2 3 4 5 6. 1 2 3 4 5 6 means here. So here there is no substituents, no worry about the secondary suffix. So this is open chain, no worry about the primary prefix. Okay, and root word. What is the root word here? 6, hex. Hex. Root word is hex. And what is the primary suffix? In. X plus in. So what is the position of in? First position. So x 1 in. So what is the name of IUPAC name of this compound? Means x 1 in. And when you remember one thing very carefully. When the position of multiple bond is 1 means you no need to write. Okay, means if we are not writing the position of the double bond, means the double bond must be present in the first position only. Okay, so some people may get, sir, it is present from 1 to 2 means, so what is the lowest number, that only we should take. Okay, here 1 is the lowest number, this is only we should take. Okay, so here hex in, which means hex 1 in. Here when 1 is there means you no need to write. Next, let us see. Same. So now what is the IUPAC name of this compound? Okay, so now first challenge is giving numbering. So what I said, when while giving numbering, we should give the lowest possible number to the multiple bond. So here what is the lowest possible number means, some people that blindly they will think and they will give starting numbering here 1. So here here this is not, this rule not says compulsory we should give number 1, but what is saying, we should give lowest possible number. So means from any one of the end we need to start. Okay, so here you no need to start here, but what we should give lowest possible number. Okay, you no need to start here onwards. Okay, so from here onwards if you start means 1 2 3 4 5 6, and here in the opposite direction also you are going to get the same 1 2 3. Okay, no problem. So now what is the name of this compound? Hex. What is the position of multiple bond? 3. So here 3 we should write compulsory, we should represent the position of the double bond. Okay, next let us take one more example. Okay, here we are going to add one more. Okay, now we are having double bonds like this. So 1 2 3 4. So what is the root word here? But. But when we are having two double bonds or two triple bonds, multiple, two double bonds or two multiple bonds means, for root word we are going to add a, buta. So here not buta, buta, a we need to add, whether it is if it is penta means 5 carbons means penta, x means hexa, like that we should add a here. Okay, so buta. So what is the position of double bonds? 1 comma 3 diene, buta 1 comma 3 diene. Di represents what? 2 times double bond is present. Okay, so this is the name of the compound. Next, so what is the name of this compound? Okay, so numbering 1 2 3 4. So but 1 ine. So ine represents what? A triple bond. Ine is what? There triple bond. Next, okay, same take you like this. So here also we are having triple bond. So now what is the name of this compound? 1 2. So this is the second carbon, 2 3 4. So what is the name of this compound? 1 3, sorry, buta. Why? Because two double bond, two triple bonds are there, so we should add a, buta 1 3 diene, like that we should give the name. Okay, now let us see some more important examples which are given in the NTA exam. Okay, into JE mains and AP set, M set. Okay, like that type of exams. Okay, some important examples here. Okay. So what is the name of this compound? Very, very important. Okay. See, many people will get confusion here. So where we are giving priority. Okay. So first let us see numbering here. So from this side 1, 2, 3, 4, 5, 6. So when you give in this direction means left to right, you are getting first position for the double bond, sixth position for the triple bond. And they will ask you immediately, sir, he said that double bond and triple bond are have same priority. So I will write from this side. So what is the wrong? 1, 2, 3, 4, 5, 6. I will name like this. Okay. But so there is no change here. There is no change in this point, that is double bond and triple bond are have same priority, and such type of examples are called symmetric cases. So equal positions double bond and triple bond is getting is that position, the type of position is called what? The type of compound is called symmetric compounds. In symmetric compounds, so what we should do when there is a competition between the double bond and triple bond, we should go through the alphabetical order. Alphabetical order important here, that point you need to keep in mind. So here in alphabetically, what is the name of this double bond? Primary suffix in, it starts with e and it starts with y. So in according to alphabetical order, which one we should give? E. So this is only correct. What I have written with black color, that is only correct, but this red color one is incorrect. So now what will be the name of this compound? So first root word x, hexa, hexa, 1 in x, 1 in 5 ion, x, 1 in 5 ion. Okay. So now let us take one more example to avoid the confusion. The same, and now I am taking the double bond here, triple bond here. Now let us give the numbering. So from which direction we should give the numbering? Okay. So 1, 2, 3, 4, 5, 6, and let us give numbering with right to left. 1, 2, 3, 4, 5, 6. See here we are getting the positions here 1 and from this 2. So according to first point of reference 1 only it is correct. So here right to left only correct, which means we are not giving any priority for the triple bond, we are giving priority for the position. Okay, here first position multiple bond is there, here from this direction second position is multiple bond is there, that's why we are giving priority for the first position multiple bond. So now what is the name of this compound? Hex. And here also when we are writing the name we will write according to alphabetical order. Hex, x, 1, 2, 3, 4 in 1 ion, 4 in 1 ion. So this type of examples are very, very important. And now let us take one more important example. Okay. Yes, this type of examples, and this type of examples. So this type of examples are very, very important here. Okay. So first let us name this one. Then after I will come here. Okay. So now let us go through the numbering. So from which direction we should give numbering? Okay. So 1, 2, 3, 4, 5. 5 only we are getting, but here 1, 2, 3, 4, 5, 6. 6. This side also we are getting 2 double bonds. Here also we are getting 2 double bonds, and here we are getting one more carbon extra. That's why we can consider this is the main carbon chain, and it will become substituent. Okay, so this is somewhat a different substituent we can see when you observe from the last examples. So this is somewhat a different type of substituent here we are having. So now, what is the name of this substituent? So here it is just looking like alkene. So when alkenes are substituents, when alkene alkene is substituent, we are going to remove E, and we are going to add oil. Okay, and remove hydrogen. So now, what is the name of this substituent? Alkynyl. Okay, alkynyl. Okay, so alkynyl. So now, let us try to name of this to give the name of this compound. What is the name of this compound will be? So the name of this compound will be, so what is the position? Third position. So 3 alkynyl. How many carbons? 1, 2 carbons. So 2 ethynyl. 2 ethynyl. Okay, root word hexa. Why? Because 2 double bonds are there, hexa, and a position of double bonds 1, 5 diene. So this is the name of this compound. Now come to this one. Okay, so now here when you give numbering 1, 2, 3, 4 carbons only, and when you give from numbering from here 1, 2, 3, 4, 5, so 5 carbons. So now left to right, this is only the correct numbering, and this is the substituent. Okay, now what is the name of this substituent? So it is just looking like alkene. Okay, so how many carbons are there in the substituent? Only 1 carbon is present. That's why it is named as methylene. So it is called, what is the name of this substituent? Methylene. Methylene, or it is also called methylidene. Methylene or methylidene. Okay, so means if double bond is directly attached to this main chain, means we use methylidene, or means only 1 carbon is there, methylene or methylidene. In this only 1 carbon case only, we use these two names of this substituent. So what is the name of this compound now? 1, 2, 3, 4, 5. So substituent is at which position? Third position. 3 methylene or methylidene. 3 methylene penta 1, 4 diene. So this is the name of this compound. Okay, next, now let us try to give the one, let us discuss one more example, important example. So what is the name of this compound? Okay, so numbering 1, 2, 3, 4, 5, 6, and here 1, 2, 3, 4, 5, 6. Okay, so now let us take one more variation, one more. Okay, right. So now let us give this double bond here. Okay, so now what is the name of this compound? So first of all, first task is selection of the longest carbon chain. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So this is the longest carbon chain, and 2 double bonds are included. So now, what is the name of this compound? What is the name of this compound? So numbering 1, 2, 3, 4, 5, 6, 7. So now this is the substituent. What is the name of the substituent? So directly double bond is present to the longest carbon chain. In that case, what we use? Alkylene. So what is the name of this substituent? How many carbons are there? 1, 2 carbons are there, means ethylene. Ethylene. So here we use ethylene. The name of the substituent is what? Ethylene. Means if the directly this double bond is attached and here x number of carbon atoms are there. So now what is the name of this complex substituent? Means, so what is the name of this substituent? Means alkylene. Alkylene. What is the name of this substituent? Means that is alkyl. So now simply we can give the name of this compound. So what is the name of this compound will be? So 7 carbon atoms are there. Hepta. Sorry, first we should write the name of the substituent. So what is the name of the substituent? Ethylene. Ethylene hepta. Ethylene hepta 1,6 diene. Okay, so this is the IUPAC names of alkenes with some special cases. Okay, so with substituents, simply substituents we can place and we can write the name of this alkenes and alkenes. Okay, thank you for watching. Okay, in next video I will explain the IUPAC names of organic compounds with the functional groups. Okay.